You've seen it a million times, right? That little S and the padlock icon in your browser's address bar? Well, today, we're going to pull back the curtain and show you what it really means, not just for your security, but for how fast your internet feels. And the answer might surprise you. So let's just jump right in with a big question that kind of flips everything we thought we knew on its head. For years, the common wisdom was that more security meant less speed. It was a trade-off. But what if that's just not true anymore? What if that little s is actually the secret to a faster web? Okay, to really get the difference here, let's use a super simple analogy. Using the old HTTP is like sending a postcard. Think about it. Anyone who gets their hands on it, from the mail carrier to the person at the post office, they can just read your message. It's totally exposed. But HTTPS, that's like putting your message in a locked steel box. Only the person with the key can ever open it. Right, so before we talk more about that awesome locked box, let's spend a minute on the postcard. Because to really understand why HTTPS is such a big deal, you have to see just how insecure the web's original protocol really was. HTTP is basically the foundational language of the web. It's how your browser asks a server for a web page and how the server sends it back. But it's got one huge, glaring weakness. It speaks in plain text. It's like having a loud conversation in a crowded coffee shop. Literally anyone listening can hear every single word. And this is where it gets really scary. That weakness opens the door to something called a man-in-the-middle attack. You've got an attacker, Mallory here, who just slips themselves right between you and the website you're visiting. And because everything's in plain text, they can read it all. Your passwords, your credit card numbers, you name it. They could even change what the website shows you, and you'd probably never even know what happened. So, with these digital eavesdroppers all over the place, how do we protect ourselves? Well, the answer was to build a much better system. It was time to ditch the postcard and make that locked box the new standard. And that's where HTTPS comes in to save the day. That S just stands for secure. It's still using the same basic language, but it wraps every single message in a powerful layer of encryption. It uses a technology called TLS to create that digital locked box, making sure your data stays private and nobody can mess with it in transit. Now, all this security gets set up in literally the blink of an eye through something called a TLS handshake. You can think of it like a secret greeting. First, your browser and the server say hello and agree on the best, strongest way to encrypt things. Then, the server has to prove it is who it says it is by showing some ID. That's the SSL certificate. Once your browser checks that the ID is legit, they both create a brand new secret key that only they know, and they use it to lock down the rest of the conversation. It's pretty cool. But of course, the story doesn't end there. Attackers are clever, and they came up with a new move. They figured out a way to trick you into dropping your locked box and using that old insecure postcard again, all without you realizing what was happening. It's a really sneaky attack called SSL Stripping. The attacker gets between you and the website right when you first try to connect. They connect to the secure site for you. No problem. But then they turn around and serve you the old, insecure HTTP version. So to the website, everything looks fine, but your connection to the attacker is completely exposed. And here's what you see. You think you're talking directly to your bank, but you're actually just handing all your info to the attacker in plain text. That little padlock icon disappears from your address bar, and you might see a not secure warning. A warning that, let's be honest, is really easy to miss or ignore. And just like that, your data is vulnerable all over again. To fight this, the good guys needed an even stronger defense. They came up with a super strict rule that basically tells your browser, listen, for this website, we don't use postcards anymore. Ever. This defense is called HSTS, or HTTP Strict Transport Security, and it's really powerful. When you visit a site that uses HSTS for the first time, it gives your browser a command. Hey, from now on, don't even think about connecting to me over insecure HTTP. Locked box only. Got it? And here's why that's a total game changer. Once your browser has that rule, it will automatically upgrade any connection to that site to HTTPS before a single bit of data even leaves your computer. This completely slams the door on those SSL stripping attacks. There's just no insecure first step for them to intercept anymore. Problem solved. Okay, now for the big reveal. Let's go back and tackle that old myth. For so long, the biggest argument against forcing everyone to use HTTPS was performance. People said all that encryption would just slow everything down. But is that still true? Well, the data says not at all. And, to be fair, for a while, that concern was valid.
That initial handshake process did add a little bit of extra back and forth, which meant a tiny bit of lag when you first loaded a site. But modern web protocols, which actually require HTTPS, have totally flipped the script. Just look at this. We're comparing the older HTTP/2 with the new and improved HTTP/3. From a server in New York, the newer, more secure protocol is already over 300 milliseconds faster. The security lock isn't a wait anymore, it's a rocket booster. Okay, now check out what happens when the data has to travel farther. Connecting to a server in London, the performance gap gets way bigger. We're now seeing a 1.2-second improvement. That's over a full second faster, just by using the modern secure protocol. You can really feel a difference of a full second. And the further away we get, the more insane the difference is. On a connection all the way to Bangalore, the speed up is a massive 2 full seconds. This is incredible proof that modern security isn't just secure, it's actually much better at handling the delays you get on long distance or even unreliable networks. So what's the magic trick here? How is this possible? It's all thanks to a new protocol called QUIC, which HTTP/3 is built on. The old system was like a single-lane road. If one car, one little packet of data got stuck, it caused a traffic jam for everyone behind it. QUIC is like a brand new multi-lane superhighway. Multiple streams of data can just flow around any problems. It's just smarter, tougher, and way, way faster. All right, let's zoom out and bring it all home. We've talked about the dangers of the postcard, the safety of the locked box, and this mind-blowing performance revolution. So what's the final verdict? Why does that one little letter in your address bar matter so much? This table really lays it all out, doesn't it? You've got HTTP on one side, plain text, totally vulnerable, and browsers literally label it not secure for a reason. And on the other side, you've got HTTPS, encrypted, trusted, and thanks to all this new tech, it's actually the faster choice for pretty much everything you do online. So, when it all boils down, it's this simple. HTTPS gives you the security you absolutely need to keep your information safe. It builds trust, not just for you, but for search engines too. And this is the big one, it busts that old myth for good by delivering way better speed. Security isn't a trade-off anymore. It's just a complete and total upgrade. And the wildest part is that all of this is happening invisibly, behind the scenes, every single time you click a link, to keep you safe and make your experience fast. Which really leaves us with one final thought. We've all been trained to look for that little padlock as a sign of safety. But what other invisible rules, what other secret handshakes are working to protect you right now?